Hello friends, in this video I am going to speak about n queens problem. Again, n queens could be solved using the backtracking technique. So I have explained in my previous video what is backtracking technique. So let us see what is this n queen problem is about. N queen problem is, so we take the value of n, okay. So n may be 0, n may be 1, n may be 2, and whatever is the n, we take an n cross n matrix or the n cross n chessboard, okay, and we have to place the queen. For example, if I take n's value to be 5, okay, then I will have an n cross n matrix, that is 5 cross 5. So my matrix or the chessboard like structure would be okay, like this. So where has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a chessboard kind of a structure, and the same rules of the chess applies of the queen moves would apply here. So now when I tell n equals to 5, it means it is 5 cross 5 chessboard, and I will have 5 queens to be placed, right? It means I have to place 5 queens in this particular square in the chessboard. The rule is, once you place a queen in particular row, okay, no queen could be placed in that row. So once you place, you cannot place any queens in that row. Then similarly, once you place a queen in particular column, you cannot place any queen in that particular column. Okay, so you cannot move, right? And another one, third rule is not even diagonally, right? Meaning, say if I place my queen 1 here, okay, I cannot place any queens in this row. So that is rule number 1. And I cannot place any queen in my column, entire column. So I cannot place any of the queens here, right? So that is my rule 2. Now coming back to this diagonally. So diagonally meaning here, I cannot place any of the queens in this particular, because here you have only one diagonal now, right now. So I cannot place. So leaving this space, you can place your next queen, right? That is how this n queen problem would work. Okay. Now let us start from what are the basic Now you understood what is n queens problem. For a given n, how could we place the n? Now where is this backtracking come into picture? Now say if n equals to 0, meaning queens are 0. So it cannot be possible. So it's not an problem. Say n equals to 1, number of queens to be placed would be 1, and the matrix would be 1 cross 1. That is nothing but this I can easily place. So this is a trivial question or solution. Not right. Then let us go for n equals to 2. So it means I have to place 2 queens. So my matrix is 2 cross 2. So it is like this. So if I place 1 cube, I cannot place here, I cannot place here, I cannot place here. So meaning the problem is not right. So you cannot, if n equals to 2, you cannot solve this particular problem. Say now I will take n equals to 3. Meaning you have to place 3 queens and the matrix would be 3 cross 3. right? Now, what if I place my queen here? I cannot place anything here, right? Not even here. So the left place is this. And if I do this, I cannot place any queen here. So meaning, I cannot place my third queen. So just say if I don't place here, and I will place my queen here, right? It means I cannot place here, I cannot place in this, and diagonally here no, and here no, right? I can only place it here, right? So in that case, in any space, if I cannot place any queen here, so there is no place for my third queen. Again we will change. What if I had placed my queen number 1 here, right? So I cannot place anything here, here, here and here. So anywhere I have to place. So if I would have placed queen 2 here, then diagonally I cannot place. It means again there is in any form you cannot place your queen 3. So meaning for the n queens problem, it should be anything n greater than 3 to resolve this. So I've shown all the cases. What if it was 0, 1, 2 and 3. Okay. So in this video, let us take the value n equals to 4. It means I have to place 4 queens. Okay. And it's a 4 cross 4 matrix. Let us see the problem now. Hope you all have understood why it cannot be 1, 0, 1, 2 or 3. Okay. Now let us go to this n equals to 4 problem. Okay. Now let us see where n equals to 4. Meaning I will have an n cross n matrix, that is 4 cross 4 chessboard, and I have to place 4 queens here in my chessboard. Okay, and we are using the backtracking method. So let me draw my chessboard here of 4 cross 4. Okay. Now, let us place our queen 1 in 1, 1 position. Right. So this. So it is, I have 1, 2, 3, 4 rows, and I have 1, 2, 3, 4 columns. Now I have to place the 4 queens. So when I've placed in this position my queen 1, I know that I cannot, in this row no more queens could be placed because it is reserved as per our rule number 1. Then as per our rule number 2, we cannot have in column 2. So this is not possible. Can I place here? No. Diagonally I cannot place. Can I place here? Yes. Definitely I can place my queen 2 here because it is not. And no question of this because I cannot place no more queen in that row. So coming to this now, definitely this was not possible. Now this is not possible because it is diagonal, and here also it is not possible because already we have, and this diagonally not possible, right? So I cannot place my queen. So now this condition here is this. So now I have to backtrack telling I am not able to place my queen 3. I can place queen 3 in the next row, but where will I place my queen 4? So it means that is not possible. So when this becomes, now what happens is, here the position of this particular queen need to be changed, right? In this case, was there any, because 1 and 2 here I cannot place, I've placed here, but because of this position there is a problem here. It means there is one more space where I can change. So instead of this, I will place my queen here. Right, let us see now what will happen. This is not possible. Here I placed, no. Now here I cannot place because it's here. Here can I place my this? Diagonally okay. There is no queen. So I can place my queen 3 in this particular position. Right. Okay. Then definitely there is no question of this here. Let me go to this. So I cannot place the here because it is of queen 2. Now this is of queen 3. There is no queen here, but diagonally I cannot place here because this is the diagonal element, and I cannot place here because already queen 2 is there in that particular column. Then where will I place my queen 4? So this is not possible. So I need to backtrack again and tell that any position need to be changed. So from here, again, this is how when I'm changing, this becomes your state space tree now. Now what happens? Now this tells, this was in previous iteration, that a position of this needs to be changed because it's not possible to hold in my chessboard the queen 4. Now, so what happens when it is false? Now, can I move my queen 3? Yes, definitely there are 2 more spaces where I can move. What happens? Now from here, I have to move this because I couldn't place 4. Can I place my queen 3 here? Is it yes? No, because it is diagonally for both the elements I cannot, and not here also. So it means I cannot place my queen 3 here. Okay, if I place in the next row anywhere queen 3, where will I place my queen 4? It means there should be change, again a backtrack of one level, that it is not possible. So the position of previous queen need to be changed so that we can accommodate more queens here. Now what happens here is, if I go to the queen here, already it has been placed at the last, I have no more. So it means it has to again backtrack to change the position of the first queen. Now it means we have to backtrack. So again I will rewrite that. Now I have to change my queen 1's position. Right. In my earlier this, when it was at first position, it did not work. So now let me put it at the second position, my queen 1. So second meaning Q3, 4, 1, 2, 3, 4. So let us see now, will this work? Right. So now I cannot place any queens in this row because I understood that as per the rule, row number 1 queen can have only one this. So now let us see for the queen 2. Can I place here? No, because it is diagonal for this queen. So there would be an attack as per the moves in the chessboard. So I would go back to this, not possible because it is the row rule, the column rule, that is rule number 2, not possible. So here, not possible because it is the diagonal rule. So now, only possibility of placing my queen 2 would be in the 4th column. So I will place my queen 2 here. There is no more. So I will now go for the queen 3. So can I place my queen 3 here? Because there is no element. So I will place my queen 3 here. Is it okay? Because it fits as per our rule number 1 and 2 and 3. All the rules abide. There is no queen in particular row, there is no queen in that particular column, and diagonally also it is okay. So now I have a queen in my third position. Third queen in my first position. And no more this, as per the rule I cannot place anyone now. So let us go for the queen number 4. Right? So in queen number 4, definitely I cannot place here because already there queen 3 is there. Can I place here? No. Can I place here my queen 4? Because there is nothing in the column, there is nothing in the row, and diagonally also I think it is not in this diagonal, not in this diagonal, not this. So I can place my queen 4 here. Okay, and once done, no more. So I have placed, I had 4 queens, so I have placed. So now queen 1 is placed at 1, 2 position. Queen 2 is placed at 2, 4 position, and queen 3 is placed at 3, 1 position, and queen 4 is placed at 4, 2 position. So can you see here, all these 1, 2, 3, 4 are different rows, and all these 2, 4, 1, 2 are different columns. So meaning when I represent also, there is no row number or column number which is same here. It means there is nowhere that we have in the one queen attacking other queen this. So we have abide by all the three rules which we had. To summarize again, once a queen is being placed, there in particular position there should be no queen in any of the row or the column respect to that, and also to the diagonal. So we have followed all that and we have placed. So this is one of the solution what we got with an backtracking method. So you can try more in the similar way if you want with what if the Q was placed at the third position. So would I get a solution? Okay. So now this is one possible solution now what we got to place the 4 queens. Okay. Now if you want, let us move and see what happens just to understand how this queen works. Now we have come to the solution, that's over. But if you want to see what if I had placed the queen in the third position. So going to that, so this is my chessboard. Now what I would do is, I would place my queen 1 in this position. Okay, right? If I place here, no more could be placed here. Now I will go. Can I place my queen 2 here? Yes, I can place queen 2 here because neither it is diagonal of this, nor the row or nor the column. Now, fine, I'm done with queen 2. Now going to queen 3. Can I place my queen 3 here? No, because it is the column rule, rule number 2. Now can I place my queen here? No, because it is diagonal to this, not possible. Can I place my queen 3 here? No, not possible because it is already this. So can I place my queen 3 here? Yes, I can place my queen 3 here because there is no column factor, no row factor, and not even any diagonal factor. So fine, I could place queen 1, 2 and 3. Now what about queen 4? Can I place my queen 4 here? Definitely no. Can I place my queen 4 here? Okay. So now it is not the diagonal of this. Okay. Not the diagonal of this and not the diagonal of this. Yes, I can place my queen 4 here. So this could be one of the solution, one more where you could place the queen. Similarly, let us try the fourth position. What would happen? Okay, so here okay, now let me place my queen at the extreme this where I have, it's in the 1, 4. Okay, now can I place my queen 2 here? Right? Yes, because nothing in a row and nothing in a column, nothing in the row, now in the diagonal. Okay. Then can I place my queen 3 here? No. Can I place here because it's the diagonal? No. Can I place my queen 3 here? Yes, I can place my queen 3 here. Right? So now if I go here, can I play, this is done now, no need to go. Now my 4. I cannot place my queen 4 here. Can I place here? No. It is the diagonal element of this. No. Definitely no. No. Meaning there would be no space. I had to backtrack. Right. So here, how many combination I would have? I would have 4 queens and 8 positions, 4 positions. So many combinations, 4 cross 4 combinations, 44 combinations I would have to place my queen over here. So we have seen how it was if I had placed in 1, what if I had placed in at 2, what if at 3 and what if at 4, and we have seen the solution. So this is how n queen would work. So similarly you can try what if n was 5, what if n was 6, what if n was 7. So you can go up on increasing the n and find the possible solution of placing the queen in your chessboard.